Hello, Precalculus student. This video is for chapter 1.3. We're talking about properties of function graph, and unless the graph is just a line, which is just go up or down, most of the time graphs fluctuate, right? Function values changes, and if we can graph it, we can actually see a visual displays of the function value. When we talk about function value, we're talking about the y value because function is used to calculate the output. So if we move from left to right and we look at how y changes, we can see that sometimes it goes up, like in this case, and when we move from left to right for x value, it drops, and we call this increasing and decreasing intervals. So at this interval, this interval from the beginning to the end is increasing. We call it the increasing interval. And when the time when y drops, then it's called a decreasing interval. And then in between them, so at a point where y doesn't change, it stays constant, where it is the highest value among its neighbor or the lowest value among its neighbor, we call those points local maximum and local minimum, local max, local mean. So these are the interesting point that we want to observe in a function graph. The other point that we're interested is zeros. Zeros are when y is 0. So when y is 0, it would be the x-intercept. So these 3 points, so this graph has 3 zeros. This one is about 3.5, this is around 0, and this is around negative 3.5, right? So these are the interesting properties of function graph. So technically, how do we know a function is increasing? Function is increasing if in the interval of a greater than b, okay, we have a greater than b. Oh no, a less than b. Moving from left to right, so a is less than b, okay. Then f of a is less than f of b. That means f of b is higher, so we say the function is increasing. The function is decreasing if a is less than b, but the function value of b is lower. It drops, right? And then what is the local max and local mean is when f of when the function value change from increasing and decreasing. So at one point it must have a this is the point where it is a local max. And the local mean is when it is changed from it was decreasing and then it changed to increasing. So that is the local mean. When is it constant? It is constant when f of x is not increasing or decreasing. So usually it's at the local maximum or the minimum point, or when there is a horizontal line, right? Zeros are the x-intercepts of the graph, so it's very easy to see. There is two more absolute maximum and minimum. We call them absolute max and absolute min, which is the highest y value for the whole graph. So for everything in the domain of function, f of x is f of c, which is at x equal to c, f of c is greater than all of them, then it's called the absolute max. And likewise, f of c is less than every single other points in the domain of f, then it's called the absolute max. But function might not have absolute max or min. It's basically the highest and lowest value of the whole graph. So sometimes if function goes to infinity at the end, then you cannot see the absolute max or min. So let's do some example. So these are the case where the graph does not go to infinity. It stops at certain points. So when the graph stops at certain point and in the interval, it is possible to find absolute max and mins. So first, interval of increasing. We can actually see it with our eyes that it is increasing here, is increasing here, right? So you can graph it. It's going up slope. So the way we document it is we'll talk about, okay, it is from x is equal to negative 3 to x equal to negative 2. So that's what we write down. And also this one, from x is equal to 0 to x equal to 2. union 0, 2. You just tell the x value. So that is the interval. So when they say interval, it's the x interval. You don't have to tell how high it goes. Okay. Interval. Decreasing interval is obviously this one, right? This kind. So this is from x is equal to -2 to 0, and also from x equal to 2 to 3. So we get this 2. What is the local max? Local max is kind of like the small mountain. When x go to the highest number, it is 16, right? Y equal to 16 when at x is equal to -2. Also, there is another local max is higher than like a small mountain. So it's at x equal to 2. Also, y equal to 16 when x is equal to 2. And what is the local minimum? That is the small valley, so it's 0. Y is 0 is the local, and x is 0. But because they stop, they don't go to infinity, we can actually talk about absolute max and absolute mean. In calculus, they will actually use the calculus method to find these numbers. You don't have to graph them and look at them. Absolutely, what is the highest value? It is y equal to 16. Absolutely, what is the lowest value? It's not equal to 0. This is only in the neighborhood is equal to 0. It's actually this number, -10, I guess, right? When we talk about maximum minimum, it's about the y value. When we talk about increasing and decreasing, it's about the x value intervals. So another example, so interval of increasing, when it's increasing, I'll just go to do like this side, right? But there is an arrow here, so it'll be negative infinity. Oh, did we talk about 0 in the last example? Oh no, 0 is, when is it equal to 0? I forgot. 0 is at x. X is equal to 0, right? And also this is like 2 point, it's not 3, 2.9. So there were 2 0. Okay, so just continue with this. Increasing is from negative infinity all the way to -3, right? Also increasing from 3 union, then go up all the way in infinity. Decreasing is here, right? You can see that it's going downhill. So it's from -3 to 3. Local max, when is the small mountain happen? And what is the y value? Would be here, right? This is the local max. I would say negative. Can I say negative? It's not a negative. I think it's 50. Y equal to 50 when x is -3. What is the local mean? This is the one, right? Locally is kind of like the small valley. Y is equal to go down to 50, -50. X is equal to -3. And also, are there any absolute max or mean? No absolute max or mean. Because they would go down all the way forever. No absolute max or mean. What about 0? So this eventually would have a 0. Let's suppose it's 5. X equal to 5. -5, 0, and 5. Right. So that's 3 zeros. So that's what you need to know about properties of a function graph. The last things we want to talk about is odd and even symmetry. So when we look at the graph, technically, graphically, if the graph had a symmetric shapes left and right, so if it goes like this on the left-hand side and it goes the same thing, I think, oops, I think it is. I think it has to be symmetrical. It cannot be just repeat. It's a symmetrical. So one good symmetrical way would be like this goes up like this, and then the other one goes up like this. So this is symmetrical. We call this kind of function even function. Okay. So technically, algebraically, you can see that when you plug in x and when you plug in negative x, the y value is the same. F of negative x is the same as f of x. So this is even. What is odd function? Odd function is when you have something here and there is another thing here, right? So anytime you have a point of x, y, there is a negative x, negative y. Always show up, and so you can say this is odd function. Okay. So technically it would be f of negative x is equal to negative of f of x. So we would look at if these two kit functions are even, odd, or neither. Oh, so one way to do it is actually graph it, right? So if I graph Q, you can see that whenever there is a 1, 1, 1, there is a negative 1, negative 1. If I have a 1 egg, there's a negative 1, negative egg, so it is odd, right? There's a symmetry. So the 1 over x squared functions are like this. Left and right are the same, so you can tell that it is even. The second and the third example would be to check if they're even or odd using algebraic method, not graphing. So what I'll do is I have f of x. I just need to calculate f of negative x and negative of f of x. So f of negative x is, plug in negative 4 times, and plug in negative square. And because negative 4 times is just positive, so this would be 3x to the fourth plus x squared. Negative of f of x is negative of 3x4 plus x squared, right? So it's negative 3x4 minus x squared. Now, check even. Even would have negative of f of x is the same as f of x. Do we have that? Actually, it is true, right? True, so it is even function, and we don't need to check odd. Okay. If it doesn't work, then you check odd. So look at this. You check f of negative x, is it the same as f of x for even? You check negative f of negative x if it is the same as negative f of x. So do the second one. We always just do f of negative x first and negative f of x. So no matter what, if we want to check even and odd. So negative f of x will be 2 times negative x 3 times minus negative x. So it would be negative 2x cubed because negative 1 3 times is negative. Negative negative is positive. Okay, negative of f of x is just negative of the whole thing. That would equal to negative 2x cubed plus x. Did you see that these two are the same? That means clearly negative f of negative x is the same as f negative of f of x. So it must be odd. And you can see that these two are not the same, not even, right? This is this one, this is this. So you can also note that f of negative x is not the same as f of x. So it's not even. The function usually is just either odd or even. Okay, so that is properties of graph. Okay, you need to know what is increasing, decreasing, and also even and odd symmetry using the graphing method as well as algebraic method.